Yes, madam.
Uh,
Yeah, now I can
yes, yes. I'm
share.
waiting for your screen. Yes, sir.
Can you see the board, madam?
ఇక్కడ display అవ్వలేదు. Yeah, waiting for that. Whether it's a PPT or document,
No, no, madam.
like
I
it's
will
on
use.
whiteboard. Okay, okay,
Yes,
okay, okay,
I will use this board, madam.
okay. Please start write something. Then I could see. Yes, 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 yes. Okay, perfectly.
Okay. Wait, madam. Just.
Second one is clear.
Yes, madam. I will use second.
Uh,
Uh,
Start the session, sir.
okay, right, madam. Yes, good afternoon, one and all. So while discussing, amma, if you have any doubts, you type in chat box. Immediately, I will give reply. So I will start from fundamentals, amma. Okay, slowly. I will teach for first classes, then I will go to little bit fast, amma. If you are good at fundamentals, then you can easily understand application part of this thermodynamics. Okay. Okay, thermodynamics. Listen carefully. Thermodynamics, amma. If you see here, we have two words. First one is thermo, next one is dynamics. So what is meaning of thermo? Thermo means heat. Thermo means heat, amma. Dynamics means power. Madam, am I audible, madam? Okay. Am I audible? If yes,
Yes, sir.
box. Okay. Right, amma. In the middle, I will ask some questions. You have to type in the chat box, amma. Right. Listen. Thermo means heat, amma. Dynamics means power. So, what is power? Power is equal to energy per unit time or work per unit time, amma. You can write anything, but here I am writing, amma, work dividing by time or work per unit time. Okay. Now, come to the heat, amma. This heat is non-organized form of energy. Why I will tell you, don't worry. Non-organized form of energy, amma. Form of energy. This power, so in this power, we'll take only work, amma. We don't focus on power in thermodynamics, amma. We'll focus mainly on work. Okay, this work is organized form of energy. Organized form of energy, amma. Organized form of energy. Now, you tell me what is the difference between non-organized form of energy and organized form of energy, amma? Suppose if you take coal, amma. Suppose if you take, amma, coal. If you ignite coal, you will get, amma, some heat energy. Some heat energy, amma. Can you use this heat energy directly? No, we cannot use this heat energy directly, amma. Suppose if you take your mobile. Suppose if you take your mobile, amma. If you want to charge your mobile, you need some electrical energy, amma. Electrical energy. So directly from electrical energy you are charging your mobile. It means you are using electrical energy directly. But For charging your mobile, amma, can you use heat energy directly? No. That's why the energy which is not utilized directly, the energy which is not utilized directly is known as non-organized form of energy. Non-organized form of energy, amma. Am I clear? Simple. If take heat, amma, the heat energy cannot be utilized to recharge mobile or to rotate any wheel, okay, etc. Therefore, it is taken as non-organized form of energy. Come to the work. Work is an organized form of energy. Organized means this energy can be utilized directly. This energy can be utilized directly. Okay, this is taken as organized form of energy. Now, what is the aim of thermodynamics? Now you can easily understand that main aim of thermodynamics. The main aim of thermodynamics is convert non-organized form of energy into organized form of energy. Organized form of energy. The main aim of thermodynamics is convert non-organized form of energy into organized form of energy. That is here you can see what is non-organized form of energy. Heat. Heat is non-organized form of energy. Then work is a organized form of energy. The main aim of thermodynamics is to convert heat into work or useful work. Useful work. Okay, this is the main aim of thermodynamics. Very simple. Very simple. The main aim of thermodynamics is to convert heat into a useful work. Here, heat is non-organized form of energy. Work is organized form of energy. It means the main aim of thermodynamics is to convert non-organized form of energy into organized form of energy. Okay, fine. Now we'll take here thermal power plant schematic diagram. Listen, this is boiler. Okay, here we have turbine. If you have any doubts, you can ask me immediately. Here we have condenser. This is condenser, pump. Okay, these are the main parts of a thermal power plant. This is boiler. B indicates boiler. Okay, we will connect boiler to the turbine with the help of pipelines. Okay, from turbine to the condenser, condenser to the tank, storage tank. Again from tank to the pump, pump to the boiler. This is the direction. Look at here. This is the direction. P indicates pump, T indicates turbine, C indicates condenser. This is storage tank. Storage tank. Okay, first we will fill water in this boiler. What is the purpose of boiler? Please type in chat box. To convert water into a steam. What is the purpose of boiler? Generally, we will use boiler to heat the water. But in thermal power plant, we will use boiler to convert this water into steam. Okay, how do you convert water into steam? By supplying heat energy. By supplying heat energy. That is heat. Just now I told you. Heat is what form of energy? Non-organized. Non-organized. Non-organized form of energy. Non-organized form of energy. form of energy, amma. Okay, fine. When we supply non-organic form of energy to the water, what happens? Water gets heated and converting into steam, amma. That steam flows through these pipes and enters into the turbine. Enters into the turbine. When the steam enters into turbine, amma, here the steam expands and rotate the turbine, amma. Steam expands and rotate the turbine. Here we are getting, amma. Okay, work, amma. When turbine rotates, we are getting some work. This is called soft work. Okay, soft work, amma. Okay, after expanding the steam in turbine, amma, then leaves the turbine and enters into the condenser, amma. Before entering the condenser, it is which state, amma? Gas state, amma. This condenser converts, okay, the steam into the water. Water is which state, amma? Liquid state, amma. Liquid state. Okay, how the condenser converts steam into water, amma? By adding heat to the liquid, by removing heat from the steam. So by removing heat from the steam, by removing heat from the steam, amma. By removing heat from the steam, this condenser converts steam into a water. This water enters into the tank, amma. Water enters into the tank. Again, this water is supplied to the boiler with the help of pump, amma. With the help of pump. It is a cyclic process, amma. It is cyclic process. So come to here, we are supplying here non-organic form of energy to the boiler. Boiler, that is heat, amma. When supply heat to the boiler, what is converting into steam enters into the turbine. In this turbine, the steam expands and gives some work, amma. Work. Just now I told you, work is a organized form of energy. Organized form of energy, organized form of energy. After this, the steam leaves, enters the condenser. Here, the steam is converting into water by rejecting heat to the surroundings, then enters into the storage tank. From the storage tank, water is supplied to the boiler with the help of pump, amma. Okay, fine. If you observe carefully in this diagram, okay, what we are doing, amma? We are converting non-organized form of energy into organized form of energy. My point is clear? I am converting non-organized form of energy, that is heat, into organized form of energy, that is work. That is work. In this power plant, amma. Now it is clear, amma. What is the main aim of thermodynamics, amma? Convert heat into useful work, amma. Useful work. That is main aim of thermodynamics, amma. Okay, fine. Now listen. This thermodynamics depends upon 4 laws, amma. Okay, we can write. First one is zeroth law of thermodynamics. This thermodynamics is based on 4 laws. This thermodynamics is based on 4 laws, amma. Zeroth law of thermodynamics, amma. Next one is first law of thermodynamics. Second law of thermodynamics. Third law of thermodynamics, amma. We will discuss one by one. Okay, listen. Zeroth law of thermodynamics, amma. Okay, first we'll see that statement, amma. We take here 3 bodies. Take here 3 bodies. Body A. This is body B. Body C, amma. If these 2 bodies, what are these 2 bodies, amma? B and C. If these 2 bodies are in thermal equilibrium with body A, these 2 bodies are in thermal equilibrium with body A, then what we can tell, amma? Then this B and C also in thermal equilibrium with each other. First, I have a simple question, Amma. For thermal equilibrium, which property should be same? Anyone type in chat box. For thermal equilibrium, which property should be same? Type in chat box. For thermal equilibrium, which property should be same? Are you listening? Sumit, am I audible? Vasiteja, okay, please give a response. Another, I ask some questions, please give response, Amma. I'm requesting. Okay, listen. Okay, now listen. I've taken, Amma, 3 bodies. Body A, body B and body C. B is in thermal equilibrium with A. C also in thermal equilibrium with A. Then B and C also in thermal equilibrium with each other. To maintain thermal equilibrium, temperature should be same. Temperature should be same, Amma. Suppose you take here 2 bodies. For understanding, I'll tell you here. Take here 2 bodies. One is steel at temperature 500 degrees centigrade, Amma. You take another one is aluminum. This temperature is 300 degrees centigrade, Amma. These 2 bodies are placed like this. Now, what happens, Amma? Forget about surroundings. These 2 bodies are completely insulated. These 2 bodies are completely insulated. Now, what happens, Amma? Heat flows from high temperature to the low temperature till both the bodies attain same temperature, Amma. Till both the bodies attains same temperature. Suppose steel comes to 400 degrees centigrade, Amma. Then aluminum also increases to 400 degrees centigrade, Amma. Then both the bodies reach same temperature. Then we can say that steel and aluminum are in thermal equilibrium. For attaining thermal equilibrium, temperature of body should be same. Temperature body should be same, Amma. Right. Now you can tell zeroth law of thermodynamics says that if B and C are in thermal equilibrium with body A, then B and C also in thermal equilibrium with each other, Amma. Each other. Okay. Now tell me, from this what you can understand, Amma? Zeroth law builds the concept of what? Temperature. For zeroth law, we need thermal equilibrium. For thermal equilibrium, temperature should be same. So zeroth law builds the concept of temperature. To come to the first law of thermodynamics. First law is basically the law of conservation of energy. What is the meaning of this one, Amma? What is the law of conservation of energy? What is the law of conservation of energy? It means
energy neither be created nor be destroyed.
Yes, excellent, Amma, excellent. Okay. We cannot create energy, we cannot destroy, Amma, but we can change from one form to another form. One form to another form, Amma. Okay. Can you give me any example for first law of thermodynamics, Amma? What is first law? Basically, law of conservation of energy, Amma. Can you give me any example for first law of thermodynamics? I will give number of examples, Amma. First, listen. Suppose take water, Amma. Suppose take water. When the water is at high level, take water. When the water is at high level, Amma, it is having which energy, Amma? Potential energy. Suppose take, Amma, this hill, Amma. This is hill. Water is flowing from top of the hill towards ground, Amma. When the water is at top of the hill, Amma, it is having potential energy. Okay, fine. Now what happens, Amma? Once the water starts flowing, what happens? The potential energy will be converting into kinetic energy. Potential energy converting into kinetic energy, Amma. Once the water reaches the ground, Amma, this kinetic energy will be converting into internal energy. Like this, energy can change from one form to another form, but the total energy of the water remains constant amma. Suppose potential energy at the point equal to take 100 joules amma. Kinetic energy also 100 joules. Internal energy also 100 joules amma. Like this, energy of the water remains constant, but energy can change from one form to another form. Can you give me any other example, amma? Can you give me another example? There are so many examples here. Suppose take petrol. It is having some chemical energy. It is having some chemical energy, amma. If you ignite that petrol, what happens? That chemical energy will be converting into heat energy. Like this, energy is changing from chemical to heat. Chemical to heat, amma. Okay, that is about first law of thermodynamics, amma. So it is basically law of conservation of energy. Okay, now I'll apply this first law for a system. So I will tell you, don't worry what is system. Okay, here I will take system, amma. I will take here system. I am supplying some 40 kilojoules of energy to the system. E in is equal to 40 kilojoules, amma. Okay, the energy coming from the system, E out is equal to say 30 kilojoules, amma. 30 kilojoules. Now apply first law of thermodynamics for the system, amma. Does it satisfy? No. Input is 40 kilojoules, amma. Output is 30 kilojoules, amma. Then what about remaining? What about the remaining? What about the remaining, amma? Remaining energy will be stored in this system. This energy is called storage energy. Storage energy, amma. That is how much, amma? 10 kilojoules. How to that equation, amma? Energy stored in the system is equal to difference in input and output, amma. That is equal to del E. Del E. Okay. Now when I apply first law of thermodynamics, okay, we got del E, amma. Del E is energy stored in a system. Generally it is taken as internal energy. Internal energy, amma. So when I apply first law of thermodynamics, we got the concept of what? Internal energy, amma. Internal energy. Okay. Come to the second law of thermodynamics, amma. Law that energy is conserved. It means it can change from one form to another form. It can change from one form to another form, amma. Okay, fine. But second law says that energy has a quality. Energy has quality and as well as quantity. First law talks about only quantity, amma. First law talks about only quantity. It never talks about quality. But second law of thermodynamics talks about quality also. Quality also, amma. Okay, listen carefully. Now take here hot coffee. Take, amma, hot coffee, amma. Leave this hot coffee at room temperature. You take this is at 70 degrees centigrade, amma. Now what happens, amma? You take, amma, hot coffee. Leave this hot coffee at room temperature. What happens, amma? Suppose take room temperature or surrounding temperature is 20 degrees centigrade, amma. What happens, amma? Heat starts flowing from this coffee to the surroundings, amma. Coffee to the surroundings, amma. Okay, fine. Now, if you apply first law of thermodynamics, what it says, amma? Heat lost by coffee is equal to
heat gained by surroundings.
Yes, very good. Gained by surroundings, amma. Heat gained by surroundings. This is possible, amma. Okay, right. Next, listen. You take, amma, hot coffee Don't take hot coffee, amma. Now take here cool coffee, amma. Cool coffee. At what temperature, amma? Room temperature only 20 degrees centigrade, amma. Its surrounding temperature is equal to 20 degrees centigrade, amma. Now tell me, this cool coffee get convert to hot coffee by itself. This cool coffee can be converted into hot coffee by itself. How? How? Heat lost by the, listen carefully, here you can write heat. So if you want to become hot coffee, amma, it has to take heat from surroundings, amma. So when I apply first law of thermodynamics, what it says, amma? That is also possible. How? Heat gained by coffee. Heat gained by coffee. Heat gain means from surroundings to the coffee, amma, is equal to heat lost by surroundings, amma. Which one is possible? Suppose this is first case, amma. Second case, amma. First case is possible. You tell me, second case is possible or not possible? Second case, amma. See, I have taken cool coffee, amma. I want to get it hot by itself. How? Take heat from the surroundings, amma. Is it possible? Is it possible? No, amma. Second case is not at all possible, amma. Heat always flows from high temperature to the low temperature. Heat always flows from high temperature to the low temperature. It never flows from low to high. From low to high. If you want to heat this coffee from 20 to 70 degrees centigrade, then heat has to flow from surroundings to the coffee, amma. What is surrounding temperature, amma? 20. What is surrounding temperature? 20. Suppose if the coffee temperature is increasing, means temperature of this coffee is increasing, means heat is flowing from low to high, amma. But practically it is not at all possible. But first law says that this is also possible. How? Heat gained by the coffee equal to heat lost by the surroundings, amma. From this, what you can understand, amma? First law simply says that energy is conserved. It can change from one form to another form. But second law of thermodynamics says that, okay, all natural process occurs only in one direction. All natural process occurs in only one direction, amma. One direction, amma. So if you apply first law of thermodynamics, both are possible. But if you apply second law of thermodynamics, amma, it says first one is possible, but second one is not possible, amma. From this, what we can understand, amma? Suppose if you have any unknown process, listen carefully. I will tell the same point in the next class also. If you have any unknown process, amma. If you have any unknown process, listen carefully. Unknown process. If you want to know whether this process is possible or not possible, how do you check? You have unknown process, amma. If you want to know whether this process is possible or not possible, how do you check, amma? Don't apply first law of thermodynamics. If you apply first law of thermodynamics, it says that heat gained by someone equal to heat lost by other one. Okay, then it will say it is possible, amma. What you need to do? Apply second law of thermodynamics. Second law of thermodynamics, amma. Okay, according to second law of thermodynamics, amma, if the process is possible, then apply first law of thermodynamics. First law of thermodynamics to get the equations, amma. To get the equations, amma. From this, what you can understand, amma? Second law gives direction for the particular process. First law gives equations for the particular process, amma. Okay, right. Now, how second law gives direction for the particular process through the concept of entropy. Through the concept of entropy. Entropy. Okay. Come to third law of thermodynamics. Third law of thermodynamics deals with absolute entropy. Absolute entropy. Okay. So entire thermodynamics is based on these four laws. Suppose if thermodynamics is a table like this, thermodynamics is a table, then these four laws are like legs. So entire thermodynamics is based on these four laws. These four laws. Okay. Now listen. In engineering mechanics, you have studied about Newton's first law, second law, and third law. What is the use of this laws, and where you will apply these laws? In engineering mechanics, you have studied about Newton's first law, second law, third law. Newton's first law, second law, third law. Okay. What is the use of these laws, and where we can apply these laws, Where you can apply these laws? Suppose take here body. Take here body. If you want to know behavior of this body, you will apply Newton's first law or second law in engineering mechanics. But in thermodynamics, we don't take bodies. We will take a system. We will take a system on which we will apply these laws to know the behavior of the system. My point is clear. In engineering mechanics, you have taken rigid body on which you are applying Newton's first law, second law, third law to know the behavior of the body. Similarly, in thermodynamics, we will apply these laws on a system to know the behavior of the system. To know the behavior of the system. Okay. Now, how to study this thermodynamics? We can study this thermodynamics in two ways. We can study this thermodynamics in two ways. First one is microscopic approach. Second one is macroscopic approach. Macroscopic approach. Okay. No, actually we don't discuss much about absolute entropy. Material science people will discuss more about absolute entropy. Okay. What is absolute entropy? When temperature is absolute zero, entropy is minimum for a pure crystalline structure. Okay. The point is clear. We don't discuss more about absolute entropy. Okay. Material science people will discuss more about absolute entropy. Right. Don't if you want. We will discuss more about that in the next class. Listen. Okay. Now microscopic approach. Listen carefully. Micro means at molecular level. You know. Micro means at molecular level. Okay, right. Listen carefully. So in this microscopic approach, we consider events occurring at individual molecules. My point is clear. In microscopic approach, we will consider the events of individual molecules. Where we will use this microscopic approach. Listen. If density is very less, okay, then we will use this microscopic approach. You may ask why. Listen. at higher altitudes, at higher altitudes, pressure is less, when pressure is less, then density also less. When density is less, okay, then the distance between the molecules is high. The distance between molecules is very high, So when distance between molecules is very high, it takes more time to collide. It takes more time to collide, It means till that time, each and every molecule will have certain velocity and certain energy, In this case, we will apply microscopic approach. When you come to the macroscopic approach, we don't take events occurring at molecular level. It means we don't take events of individual molecules. Why? Because at the ground level, means near to the earth, density is very high. Density of air is very high. When density is very high, the distance between the molecules is very, very less. The distance between molecules is very, very less. When the distance between molecules is very less, within fraction of time, one molecule will collide with another molecule. In this case, it is very difficult to study behavior of individual molecule. Am I clear? In microscopic approach, we will see behavior of individual molecule. Okay? In macroscopic approach, we don't see behavior of individual molecule. Why? I'm telling. Okay? When density is very high, if pressure is high, then density also high, When density is very high, the distance between the molecules is very, very less, When the distance between the molecules is very, very less, okay, then molecule will collide with another molecule within less time, within very, very less time. Now what happens? When molecule will collide with another molecule within less time, it is very difficult to measure velocity, etc. for individual molecules. Then what we will take in macroscopic approach? In macroscopic approach, we will take average values of various molecules. Average value, not value, it is average value. Average value of various molecules is taken into account. I am repeating once again. Listen carefully. This is very, very important. Listen carefully. Repeating once again. Okay? Okay, listen. In microscopic approach, we are considering behavior of individual molecule. In microscopic approach, we are considering behavior of individual molecule. Okay. Where we will apply this microscopic approach? Next question is, where we will apply this microscopic approach? Where density is very less. In that case, we will apply microscopic approach. When density is very less, then the distance between the molecules is very high. When the distance between molecules is very high, then molecules can move freely for a certain distance without collisions. Molecules can move freely for a certain distance without collisions. Then we can easily measure velocity, etc. for individual molecules. Okay, come to the macroscopic approach. In macroscopic approach, we don't see the behavior of individual molecule. We will take the average value of various molecules. Why? At the ground level, pressure is very high. When pressure is very high, then density is also very high. When density is very high, the distance between the molecules is very, very less. When the distance between molecules is very, very less, then molecules collide with another molecule within fraction of time, amma. Within small period of time, one molecule will collide with another molecule, amma. In this small period of time, okay, very, very difficult. So we are taking average value of various molecules. Suppose if take your class, amma. What is total strength in the class, amma? 60 members. 60 members, amma. So roll number 1, 2, and so on. 60 mm. Okay. In microscopic approach, amma, we will see thermodynamic subject marks for first student. Suppose out of 100 you got 75. Second student you got some 80. Like this, amma. We will take individual student marks. In microscopic approach, we will consider individual marks of the student in each and every subject, not only in thermodynamics, in mechanics of solids, in theory of machines. Okay, in microscopic approach, we'll consider individual marks of the student in each and every subject, But when you come to the macroscopic approach, we don't see the marks of individual subject for each and every student. We will take what are the average marks in thermodynamics, average marks. What are the average marks in MOS? What are the average marks in term for entire class? This is the difference between microscopic and macroscopic approach. Okay, right. So in our thermodynamics, which one we are following? Type in chat box. Microscopica, macroscopica. Type in chat box. In this thermodynamics, which one we are following? Macroscopic approach, microscopic approach. Please type in chat box. Yes, very good, Smith. Very good. Okay, very good. Normally, only 2 people has given the play. What about the remaining students? Out of 5, only 2 people has given the play. Remaining? Vasuteja. Okay, right. Very good. Right, legend. So in our thermodynamics, we are Am I audible? Sorry, my just now the call has gone. I connected using mobile network. Am I audible?
Yes, sir,
So
you're audible.
yes, okay. Right, Amma. Listen. So we are following, Amma. In other words, we are following macroscopic approach, Amma. Not microscopic. We are following macroscopic approach. So in macroscopic approach, Amma, we will try to get relation between measurable properties and non-measurable properties, Amma. You may ask one question. Sir, what do you mean by measurable properties and what do you mean by non-measurable properties, Amma? Suppose take pressure, okay, temperature, okay, volume, okay, mass, etc. are called measurable properties. We can measure directly. These properties can be measured directly. Okay. Now we take internal energy. Yes. Okay, ma'am. Now can you see the board?
Yes, sir.
Yes. Okay, right. Now pressure, temperature, volume, mass, etc. are called measurable properties. You can measure directly this properties. Then what about non-measurable properties? These are called measurable properties. Okay, internal energy, enthalpy, okay, entropy, etc. are called etc. Non-measurable properties. Non-measurable properties. Okay, so in macroscopic thermodynamics, we will try to establish the relation between measurable properties and non-measurable properties. We can measure these properties directly. Once we can measure this property directly, then we will try to establish relation between measurable and non-measurable. How? U is non-measurable property. What is between non-measurable and measurable? U is equal to mCV into T2 minus T1. Once you know mass, temperatures, and CV, so all these are measurable properties. You know all measurable properties. Then calculate non-measurable property. Next one is enthalpy. H equal to U plus PV. P and V are measurable properties. You will get this is you will get from here. Once you will get from here, then you can calculate H also. Like this, we can get relation between measurable and non-measurable properties in macroscopic approach. Macroscopic approach. Right. Now I will discuss quickly what we have discussed so far. Okay. First one, tell me quickly. You tell me. Thermo means what? Thermo means yes, very good, Thermo means heat, very good. Okay, please everyone give reply, Thermo means heat, Okay. Dynamics means power. Dynamics means power. What is power? Power equal to work per unit time. Okay. Now we know heat is a non-organized form of energy. What do you mean by non-organized form of energy, What do you mean by non-organized form of energy? The energy which we cannot utilize directly. The energy which we cannot utilize directly. That is called non-organized form of energy. Organized form of energy means we can utilize directly. Suppose electrical energy, that we can utilize directly to charge your mobile. That is organized form of energy. Now we are having heat energy. With the help of heat energy, can you recharge your mobile? No. Therefore, it is non-organized form of energy. The aim of thermodynamics is to convert non-organized form of energy into organized form of energy, that is heat into work. Okay, right. Right. The main aim of thermodynamics. Next one is entire thermodynamics is based on these four laws. First one is zeroth law of thermodynamics. Zeroth law of thermodynamics builds the concept of temperature. First law of thermodynamics is basically law of conservation of energy. It builds the concept of internal energy. How you can tell? Suppose if I take 100 kilocalories of food, if you are not doing any physical exercise, what happens? That 100 kilocalories of energy will be stored in our stomach in the form of fat. That is nothing but internal energy. First law of thermodynamics builds the concept of internal energy. Second law of thermodynamics builds the concept of entropy. Entropy is nothing but direction. You can write another name for entropy is direction. It gives direction for a particular process. Third law of thermodynamics deals with the absolute entropy. Okay. Next. So we can study thermodynamics in two ways. First one is microscopic approach. Next one is macroscopic approach. In microscopic approach, we will consider behavior of individual molecule. In microscopic approach, we will consider behavior of individual molecule. This microscopic approach is also known as, statistical thermodynamics. Statistical thermodynamics. And this approach is useful at higher altitudes. Where density is very, very less. Okay. Then in microscopic approach, we do not consider behavior of individual molecule. We will consider average values of various molecules. Average value of various molecules. Okay. In our thermodynamics, we are following macroscopic approach only. This macroscopic approach try to establish the relation between measurable properties and non-measurable properties. So measurable properties, examples, pressure, temperature, volume, mass, etc. These properties can be measured directly. These properties cannot be measured directly. So using these measurable properties, we need to calculate internal energy, enthalpy, entropy, etc. Okay, right. Till now, I hope it is clear. Now we are entering into the system. Okay. System. Can you tell me definition for system? Can anyone tell me what definition for system? Okay. I will give beautiful definition. Listen. What is system? Certain quantity of matter. Certain quantity of, yes, it is experimental space. Okay, right. Okay, good. Certain quantity of matter or this gap, why I will tell you later. Or certain region in space, upon which continuation, upon which attention is focused, upon which attention is focused. Now, listen. So certain quantity of matter, certain quantity of matter is nothing but mass. Certain quantity of matter is nothing but mass. This is nothing but mass. Certain region in space is known as volume. So what is system? It is a certain quantity of matter or region in space upon which attention is focused. Upon which attention is focused. Okay. Now you take here cylinder, piston. Cylinder, piston. Okay. Now fill some gas. Fill some gas inside this piston cylinder arrangement. Fill some gas inside this piston cylinder arrangement. When I supply certain amount of heat, when I supply certain amount of heat, okay, when I supply certain amount of heat, what happened to this gas? I want to see what happened to this gas. It means I am focusing my attention only on the gas, not on a cylinder, not on a piston. What I am doing? Take cylinder, piston, fill some gas inside this piston cylinder arrangement. This is gas. When I supply certain amount of heat, I want to know what happened to this gas. It means I am focusing more attention only on gas. Okay, gas molecules get excited, that we will see in the next coming class. Here my attention is, I am focusing my attention only on gas. Therefore, this gas is taken as a system. Okay, the gas is taken as a system. The gas is taken as a system. Okay. Now suppose take here one tank. One tank. Fill some water in this tank. Fill some water in this tank. Fill some water in this tank. Okay. Now I am focusing only on this water. I am focusing only on this water. Then I will take this water as a system. I will take this water as a system. It means the water as a system. Okay, right. Now next one is surroundings. Listen carefully. Surroundings. Surroundings. So what is surrounding? Everything external to the system, everything external to the system is known as surroundings. We will discuss one more word, that is boundary. Then I will explain in detail. Boundary. Okay, it separates system from surroundings. From surroundings. Okay, fine. We learned three words. System, surroundings, boundary. System means it is certain quantity of matter or region in space where our attention is focused. Where our attention is focused. Surroundings, everything external to the system. Everything external to the system. Boundary, it separates system from surroundings. Okay, again come back to this diagram. Okay, come to the diagram. Right, listen carefully. Now I have taken gas inside this piston cylinder arrangement. Piston cylinder arrangement. I want to do analysis only on this gas. I want to do analysis only on this gas. Therefore, this gas is taken as a system. The gas is taken as a system, Amma. Now tell me, this cylinder, piston, and outside becomes surroundings, Amma. Cylinder, piston, and outside area becomes surroundings. Surroundings. Now, what is boundary? What is boundary? The line which separates the system from surroundings is known as boundary. If I am using this color, listen carefully. Now, this system, so this dotted lines, this dotted lines separates the system from surroundings is known as boundary. Boundary, boundary. Come to here. Here I have taken tank, fill some water in this tank. I want to do analysis only on the water. That's why I'm taking water as a system. Water as a system, Now draw the dotted lines around this system. Draw the dotted lines around this system, Now this dotted lines represents boundary. The dotted line represents boundary. Now the tank and outside area becomes surroundings. The tank and outside area of the tank becomes surroundings. Becomes surroundings. Okay. Now we have two types of boundaries. Listen carefully. Two types of boundaries. One is fixed boundary. Real boundary. Another one is imaginary boundary. So what is boundary, The line which separates the system from surroundings is known as boundary. Okay, we have two types of boundaries, real boundary. Another one is imaginary boundary. Again, this real boundary is divided into two types. First one is fixed real boundary, moving real boundary. Moving real boundary. Okay. First we'll discuss about real and imaginary. Real and imaginary. Okay. Listen. You take here one tank. One tank. Fill water in this tank. Fill water in this tank. I want to do analysis of this water. Then this water is considered as a system. I want to do analysis only on this water. Therefore, I will consider this water as system. Water as a system. Now, draw the dotted lines around this water. Draw the dotted lines around this water. This dotted line represents boundary. The dotted line represents boundary. Now tell me, here there is no wall. Look at the cursor. Here there is no wall. I will use this color. Here there is no wall. We have done this dotted line. It becomes imaginary boundary. Imaginary boundary. Here we have walls of the container. Walls of this wall, inner walls of the container. Inner walls of the container acts as a boundary. Therefore, they are called real boundary. Okay, I hope this is clear, Here we have a walls, The inner walls of this tank acts as a real boundary. But here we don't have any wall, We have done simply dot lines. Okay, this dot line is some imaginary boundary. Imaginary boundary, Now I will draw one more diagram. Tell me which one is real boundary and which one is imaginary boundary. This is nozzle. nozzle. Fluid is entering into this nozzle, amma. Okay, fluid is entering into this nozzle, amma. Like this. Now you draw the dotted lines around this fluid. Tell me which one is imaginary boundary. I'm giving numbers 1, 2, 3, 4. Which one is imaginary boundary and which one is real boundary? Type in chat box, amma. Type in chat box. Type in chat box. Right, legend. This is nozzle, amma. Left is real. No, 1, 2, 3, 4 is no, amma. No. Legend. First we see 2 and 4, amma. 2 and 4. At 2 and 4 we have this nozzle wall, amma. Nozzle wall. The nozzle wall inner surface acts as a boundary. The nozzle wall inner surface acts as a boundary, amma. Therefore 2 and 4 are real boundaries, amma. Real boundaries, amma. Come to the 1 and 3, amma. Here you don't have any wall. Here also you don't have any wall, amma. Therefore 1 and 2 are imaginary boundaries, amma. Imaginary boundaries. Okay, right. I'll take one more example. You take your water bottle, amma. Take your water bottle. Fill half of the water. Fill water up to here, amma. Water up to here. And here I am focusing only on this water in this bottle, amma. I am focusing only on this water in this bottle. Okay, that's why the water becomes a system. Now this dot line becomes a boundary. The dot line becomes boundary, amma. So tell me, I'm giving numbers 1, 2, 3, 4. Out of this 4, amma, tell me which one is real boundary and which one is imaginary boundary. Type in chat box. If you type in chat box, then I will be very happy and I can teach very effectively. Type in chat box. Out of this 4, which are imaginary boundaries and which are very good, Sumit? Which are imaginary and which are real? Yes, very good, amma. Fourth one is imaginary. Remaining 3 are 1, 2, 3 are real boundaries, amma. Real means the inner surface of this water bottle. Listen carefully. The inner surface of water bottle acts as a boundary. The inner surface of water bottle acts as a boundary, amma. But here there is no any surface. There is no any surface, amma. Therefore 4 becomes imaginary. Remaining all are real boundaries, amma. I hope it is clear. Okay. What is next one, amma? Real boundary is divided into 2 types, amma. Fixed boundary. Another one is movable boundary. Fixed boundary. Another one is movable boundary, amma. You take here cylinder, piston. Cylinder, piston, amma. Okay. I am providing some locks to prevent the motion of the piston. I am providing some locks to prevent the motion of the piston. Now fill some gas inside this piston cylinder arrangement. Okay. When I supply some amount of heat to this gas, I want to know what happened to this gas. It means I am doing analysis only on the gas. Therefore, the gas is taken as a system. When gas is taken as a system, draw the dotted lines around the system. This dotted line becomes a boundary. Boundary amma. Since the piston is fixed amma, all boundaries of the system are fixed boundaries. This is also fixed boundaries. Fixed boundaries. Fixed boundaries amma. All are real and fixed boundaries. Okay? Real and fixed boundaries amma. Suppose if you remove this locks, suppose if you remove this locks amma, suppose if you remove this locks, what happens amma? Remove this locks amma, like this. Okay, now supply certain amount of heat, certain amount of heat to this gas or system. What happens amma? The temperature of this gas increases, pressure also increases amma. The increase in pressure will be acting on the piston of the cylinder. What happens amma? Piston will move from here to here amma. Piston will move from here to here. When piston is moving amma, from here to here, the boundary also, see here, before moving piston amma, the boundary is here. When the piston moving from 1 to 2, the boundary also moves from here to here amma. So this is taken as movable boundary. Movable boundary amma. Movable boundary. Okay, good. What distance decreased amma? I'm not getting. Okay, forget about distance amma. But here, when we supply certain amount of heat to the gas, what happens amma? Temperature of the gas and pressure of the gas increases. When pressure of the gas increases, then the pressure force will be acting on the piston. When pressure force is acting on the piston will move from here to here. From here to here amma. When the piston moves from here to here, the gas is expanding like this. See here. This is initial position of the piston. This is boundary of the system. Okay. These three are fixed boundaries. Okay. This is only movable boundary amma. Movable boundary. If you supply certain amount of heat to this system, what happens amma? Pressure of the system increases. That pressure will act on the piston amma. When the pressure is acting on the piston, what happens amma? The piston will move upwards amma. The piston moves from here to here. When piston moves here to here, the boundary also moving from here to here amma. See, before supplying heat, this is the boundary amma. After supplying heat, this is the boundary. It means boundary is moving from here to here amma. Here to here. It means in closed system, suppose if take amma, closed system amma, if you want to get displacement work amma, at least one boundary must be a movable boundary. At least one boundary must be a movable boundary. What is displacement work? We'll see later. Okay. Here, in case of this case, in this case, tell me now. If you provide locks to prevent the motion of the piston, all boundaries are fixed boundaries. So all boundaries are fixed boundaries. When all boundaries are fixed, displacement work in this case equal to how much? Displacement work in this case equal to how much? 0. It means if you want to get any displacement work in a closed system, at least one boundary must be a movable boundary. One boundary must be a movable boundary. Now, last point regarding boundaries. This boundary has, listen, this boundary is having negligible thickness or 0 thickness. This system boundary is having negligible thickness, When it is having negligible thickness, amma, it has neither mass nor volume. It has neither mass nor volume. Okay, my point is clear, amma? Boundary is having zero thickness, amma. When boundary is having zero thickness, amma, it has neither mass nor volume. Amma. Okay, right. Tell me, amma. Types of boundaries. We have two types of boundaries, amma. Fixed boundary. Another one is, sorry, two types of boundaries. Real boundary. Another one is imaginary boundary, amma. Imaginary boundary. Real boundary is divided into two types, amma. Fixed and moving, amma. In case of closed system, if you want to get displacement of amma, at least one boundary must be a movable boundary. Okay. What is thickness of boundary? Type in chat box. The thickness of the boundary is negligible or zero. Okay, right. Next, come to the types of systems, amma. Types of systems. On what basis systems are classified, amma? Listen. Based on the certain quantity of matter and certain quantity of or region in space, amma. Based on certain quantity of matter or region in space, systems are classified into three types, amma. That is closed system. Next one is open system. Open system. Third one is isolated system. We will discuss one by one clearly. Isolated system. Right. Now I am repeating once again. Based on the certain quantity of matter or region in space, systems are classified into closed system, open system, and isolated system. Okay, first we will discuss about closed system. Okay, you take here system. This is system. Draw the dot lines around the system. This dot lines depends on boundary. Okay, next, everything external to the system is taken as surrounding sum. Everything external to the system is taken as surrounding sum. In case of closed system, there is no mass flow across the boundary. M dot in is equal to 0, M dot out is equal to 0. There is no mass flow across the boundary of a system, but the energy transfer may takes place. Across the boundary of the system. Energy transfer may take place across the boundary of the system. In thermodynamics, you will consider only two types of energy, that is heat and work. Now tell me, when there is no mass transfer across the boundary of system, the mass of this closed system remains constant. When the mass of closed system remains constant, then this closed system is also known as control mass system. Control mass system or non-flow system. When there is no mass flow across the boundary, then the system is called control mass system or non-flow system. Okay, right. But there is energy transfer across the boundary of a system. Can you give me any example for closed system? Can you give me any example? You take here rigid container. This is rigid container amma. Okay, fill some gas in this rigid container amma. Fill some gas in this rigid container amma. Now I am taking this gas as a system. Now the dot line appears amma. Boundary. The dot line appears boundary amma. The dot line appears amma. Boundary. Now energy. Suppose take supply heat amma. Heat like this. Okay, Q. Energy transfer takes place across the boundary of a system. Boundary, see here. Energy transfer takes place across the boundary of a system, but there is no mass. No mass transfer across the boundary of a system. This is a closed system. This is a closed system. Then tell me what are boundaries? All boundaries of this closed system are fixed boundaries. All boundaries of this closed system are fixed boundaries. Fixed boundaries. Okay, just now told him, if you want to get any displacement work in a closed system, at least one boundary should be a movable boundary. At least one boundary should be a movable boundary. We can take one more example. What is the example? Piston cylinder arrangement without valves. This is cylinder piston. Here I have not provided any valve. Fill some gas inside the piston cylinder arrangement. The boundary. Okay. Now supply certain amount of heat. Supply certain amount of heat to the system. What happens? Supply certain amount of heat to the system. Then what happens? The temperature and pressure of gas increases. The increase in pressure will act on the piston. The piston will move from here to here. When piston is moving from here to here, the boundary of the system, this boundary will move to here. Therefore, this is movable boundary. Movable. Remaining three are fixed boundaries. So, in case of any closed system, if you want to get displacement work, at least one boundary must be a movable boundary. At least one boundary must be a movable boundary. Right. This is about closed system. Next one is open system. Take here. Take here. System. Okay. Now this dot line appears boundary. Boundary is boundary. Okay. In this system, mass enters and mass leaves. Energy enters, energy leaves. Energy leaves. It means in case of open system, both mass and energy transfers across the boundary of a system. Across the boundary of a system. Okay. Now tell me, I will ask simple question. Okay, you take with water heater. Water heater. This is water heater. For understanding different closed and open, I take water heater. Okay. From here, water enters into the tank. This is water heater. Okay. Here we have a heater. Here we have a heater coil. This is heater coil. Okay. From here the water enters. From here the water leaves. From here the water leaves. Suppose if you want to know how much amount of heat we are giving to the water, which one is considered as a system here? My point is clear. I have taken here heater. Heater heats the water. Okay. In this case, how much amount of heat given to the water? In this case, how much amount of heat given to the water? If you want to calculate how much amount of heat given to the water, which one is taken as a system? can I take the water as a system in this case? Suppose if take water. Water is filled completely. Can I take water as a system, Amma? Water means, can I take water as a system? I can't take water as a system because the water enters. When you open this tap, Amma, the water leaves, Amma. Here, water mass is not constant, Amma. Mass of the water is not a constant, Amma. In this case, we don't consider this mass of the water as a system. In this case, we don't consider this mass of the water as a system, Amma. Then which one is considered as a system, Amma? Okay, the region. I'm using red color, Amma. The region is taken as a system, Amma. This region, the inner walls of the water heater is taken as a system. This is called certain region in space, certain region in space. This region is taken as a system. Now, when you take certain region taken as a system, now here the mass enters and mass leaves. This region, you take this one. Don't take bottom. Okay, here you have a water column. Okay, I'm taking the inner walls of the water heat is taken as a system. Now mass is entering the system, mass is leaving, and heat is also crossing across the system. Heat is crossing across the system. Therefore, the system is open system. In case of open system analysis, we don't consider certain quantity of matter as a system. We don't consider certain quantity of matter as a system. Certain quantity of matter is nothing but mass. I told you clearly in the starting, certain quantity of matter is taken as a mass. Okay, in case of open system analysis, we don't consider certain quantity of matter as a system. Then which one will consider in case of open system? Which one will consider? Certain region in space. Certain region in space is taken as control volume. Certain region in space is taken as control volume. Control volume. So therefore, this is control volume. Control volume. Now the boundary of the control volume, look at here. The boundary of the control volume is taken as control surface. The boundary of the control volume is taken as control surface. Finally, you understood clearly that? Listen. In case of closed system, mass remains constant. In case of open system, volume remains constant. Therefore, it is taken as control volume. It is taken as control mass. And a closed system is also known as control mass system. Open system is also known as control volume system or flow system. Flow system. That can call flow system. Okay, can you give me any example for this open system? Open system example. Most of the engineering devices are open systems. Example, turbine, compressor, okay, pump, etc. All are open systems. All are open systems. Last one, isolated system. So if take any system, take any system. Now draw the dot lines around this system. This dot line is boundary. Now, when the system is considered isolated system, if there is no mass, m dot in is equal to 0, m dot out also equal to 0. Then E in, energy in is equal to 0. Energy out also equal to 0. It means when there is no mass and no energy transfer, when there is no mass and no energy transfer across the boundary of a system, across the boundary of a system, then the system is taken as isolated system. For isolated system, mass remains constant because there is no mass flow across the boundary. Hence, mass remains constant. Then there is no energy flow across the boundary. Hence, energy of system remains also constant. Okay. Example, thermoflask is best example for isolated system. Thermoflask is best example for isolated system. And one more system, that is universe. What is universe? Universe means called system plus surroundings. System plus surroundings. You take the universe. Okay. It is best example for isolated system. Isolated system. Okay, right. Now I want to highlight 3 points. Listen carefully. In a closed system, we will take certain quantity of matter. Okay, certain quantity of matter is nothing but mass. In a closed system, we will take certain quantity of matter as a system. Okay, in an open system, we will take certain region in space, nothing but volume. Certain region in space, nothing but volume is taken as a system. So this volume is known as control volume. The boundary of this control volume is taken as control surface. Control surface. In closed system, mass remains constant. In open system, volume remains constant. In isolated system, mass and energy both remains constant. Which one is best example for isolated system? Thermoflask and universe. Universe is equal to system plus surroundings. System plus surroundings. Right. Okay. Now I'll ask questions. You answer quickly. Closed system, open system, isolated system. Take here. Mass, energy. Here, which one is constant? Okay, tell me. In a closed system, what happens?
Energy is constant.
No. Energy transfer takes place across the boundary. Mass remains constant. In a closed system, mass remains constant. Why? Look at here. There is no mass flow across the boundary of the system. See here. No mass flow across the boundary of a system. No mass flow across the boundary of a system. When there is no mass flow, the mass of this closed system remains constant. Therefore, closed system is also known as control mass system. Control mass system. Okay, na? Now tell me, in a closed system, which one remains constant? Tell me, no problem. Even though it is mistake, no problem. Tell me, in a closed, which one is constant? Mass is constant. But here, there is no mass flow across the boundary. There is no mass flow across the boundary. But there is energy flow across the boundary of system, and mass of the closed system remains constant. Okay, come to the open system. What happens? Both mass and energy transfers across the boundary of a system. Both energy and mass transfers across the boundary of a system. Very good, very good. Okay, here which one is constant? Volume is constant. Volume is constant. Okay, in isolated system, no mass transfer across the boundary, no energy transfer across the boundary. When there is no mass transfer, then mass of the system remains constant. When there is no energy transfer, energy of the system remains constant. Very good, very good. Mass equal constant. Okay. What is the another name for closed system, amma. What is the another name for closed system? Mass remains constant now. That's what it is called. Control, yes, non-flow or both are correct, amma. Control mass system or non-flow system, amma. Okay. In open system, amma, we are considering volume is constant, amma. That's what it is called. Control volume system or flow system. Flow system. Okay, very good. Come to the isolated, amma. There is no particular number for isolated, amma. But energy of the system remains constant. Mass of the system remains constant, amma. This is regarding types of systems, amma. Okay, I hope it is clear. Okay, next one is properties. Okay. Properties, amma. Okay. Further about properties, amma. If I ask what are the properties, what you will tell? If I ask any one of you, what are the properties, what you will tell? You will tell your bank balance, your properties, your qualification, your height, your weight. All these are called properties belongs to you. Suppose if take X person, amma. Suppose if take X person, amma. X person weight equal to 75 kg, height equal to 158 centimeters. Okay. Then qualification, amma, B.Tech, first year. What else? He's having 2 siblings. Okay, he's having 2 sisters. Okay, he's having 50 C property. He's having 100 acres land. Okay, they are called properties belongs to X person, amma. Suppose he completed B.Tech, amma. Okay, he completed B.Tech, amma. If you want to join in any job, which property is important, amma? Height, siblings, property, so cash, land, which property is important for joining in any job, amma? Qualification is important, amma. So this qualification is important for joining in any job. Suppose if he want to, okay, forget about him. If any lady parents వాళ్ళ అమ్మాయికి ఈ అబ్బాయిని చూస్తున్నారమ్మా. ఓకే, ఒక అమ్మాయి తల్లిదండ్రులు ఓకే ఈ సంబంధం చూస్తున్నారమ్మా, ఈ అబ్బాయిని చూస్తున్నారు. వాళ్ళు ఏం చూస్తారమ్మా, వాళ్ళు ఏం చూస్తారు? అబ్బాయి హైట్ చూస్తారు. ఓకే, దెన్ జాబ్ చూస్తారు, సిబిలింగ్స్ ఉన్నదా లేదా చూస్తారు. ఓకే, అండ్ క్యాష్ ఉందా లేదా, ప్రాపర్టీస్ ఉన్నాయా లేవా, అంటే దే విల్ సీ హిస్ సాలరీ ఆల్సో. They will see all these things, amma. But when it comes to the job, he need only qualification. Suppose if you want to go for any constable job or any police job, amma, they will see only 2 things, amma. His weight and height. They don't want his siblings data or properties data, amma.
Education also important.
Yes, education. Yeah, very good. Education is important, amma. They will see education, amma. Very good. So all these are called properties of X person, amma. Similarly, if take any system, amma, if take any system, okay, this system properties, sorry, this system condition is represented by properties, amma. The system condition is represented by properties. What are the properties, amma? What is the pressure of the system? What is the temperature of the system? What is the mass of the system? Okay, what is the volume system? So all they are called properties. This properties represents condition of the system. This properties represents condition of the system. See here, education, height, weight, qualification, siblings, okay, cash, okay, and land and salary, okay, represents condition of this X person, condition of this X person. Similarly, so pressure, temperature, mass, volume, density, etc. represents condition of this system. Condition of this system. Now tell me, what is property? Properties are characteristics. Properties are characteristics by which we can describe the physical condition of the system. Properties are characteristics by which we can describe the condition of the system. Condition of the system. Okay, right. Right. Now tell me properties, just now told you. Pressure, volume,
Temperature.
Mass, then internal energy, enthalpy, okay, entropy, okay, then like this, etc. are called properties. Okay, right. Now this properties classified into two types, okay. First one is intensive properties. Intensive, another one is extensive properties, extensive. So tell me, intensive means independent of
Mass.
or very good, or size of the system. Independent of mass or size of the system. Okay. Extensive means depends on mass or size of the system. Okay, size of the system. Okay, we have this many properties. How to identify which property is intensive and which property is extensive? How to identify which one is intensive and which one is extensive? Okay, listen. I will give simple technique. You take one container. Take here one container. Fill some gas in this container. Fill some gas in this container. Okay. Mass of this gas. Take mass of this gas equal to say 1 kg. Volume of this gas equal to 1 meter cube. Okay. Temperature of this gas equal to say 40 degrees. Pressure of this gas is equal to, take here, 2 bar. 2 bar. What I am doing, I am going to divide this system into two equal parts. This system into two equal parts. I will divide this one two equal parts. Now this is first half. This is second half. Second half. Now tell me, once you divide this system into two equal parts, mass of the system remains same, divided into two equal parts. Mass of the system remains same, divided into two equal parts. Initial mass equal 1 kg. I have divided the system into two equal parts. Then mass also divided into two equal parts. Then what happens? Initial mass equal 1 kg. Once you divide the system into two equal parts with help of any valve, then mass also becomes half. Then it becomes m by 2. Here also m by 2. It means mass is depending upon the size of the system. If size of the system is more, mass also more. If size of the system is less, then mass also less. Tell me now, mass is intensive property na extensive property na? Mass is intensive or extensive? That is simple logic here. Why you are unable to tell you? See, you take one system. What is system here? Gas. Okay, gas is taken in a container. Mass of the gas equal to 1 kg, volume of the gas equal to 1 meter cube, temperature of the gas equal to 40 degrees, pressure of the gas equal to 2 bar. If you divide this system into 2 equal parts, or divide this gas into 2 equal parts, what happens? Mass becomes half, m by 2, m by 2, volume also becomes half, then temperature, before dividing, temperature equal to 40 after division also temperature of the gas equal to same 40. So temperature here and here same. Then here T, here also T then what is pressure? Pressure is also same. Before division, after division, pressure is same. Now look at here. Mass is depending upon the size of the system. When size decreases, mass also decreases. Therefore, mass is an extensive property. Then volume is also a extensive property. Then temperature and pressure. Temperature and pressure are not depending upon the size. Whatever may be the size, the temperature and pressure remains same. Therefore, temperature and pressures are intensive properties. Intensive properties. Okay. I will ask simple question. What about density? Density is intensive or extensive? Okay. I will close this class within 5 minutes, Tell me, Yes, very good, Density is extensive. How? Look at here. What is equation for density, Density is equal to, very good. Density is equal to mass by volume. Density equal to mass by volume, So just now I have seen, mass is extensive property. Volume is also extensive property. That's why I'm telling it is extensive. But no, it is not an extensive property. Suppose take water. What is density of water, Density of water is equal to 1000.
1000.
Yes, kg per meter cube. If take large quantity of water or small quantity of water, large quantity of water or small quantity of water, the density of the water remains same. For this one, density is 1000 kg per meter cube. For this one, density is 1000 kg per meter cube. Therefore, density is independent of the size of the system. Okay. You can tell one more point. What is point? What is density? Density is ratio of mass by volume. Mass is extensive. Volume is also extensive. It means the ratio of two extensive properties is always intensive property. The ratio of two extensive properties is always intensive property. Okay, correct. One more. Okay. Specific energy sum or specific properties. Specific property sum. What is specific property? Property dividing by mass. Example, specific volume equal to volume by mass. Volume is extensive property. Mass is also extensive. But the ratio of two extensive properties is always intensive property. Intensive property. From this you understand 2 points. First point, the ratio of two extensive properties are intensive, and specific properties also intensive. Specific properties also intensive. What is specific property? Property per unit mass. Okay, right. Then specific energies, energies are extensive, but specific energies are energies like kinetic energy, potential energy, etc. What is kinetic energy equation? Half mv square. What is the equation? mg h. If m is involved, then it is a extensive property. Now take specific energies. specific energies amma. Energies. What is specific energy? Energy per unit mass amma. Energy per unit mass. Okay, you take kinetic energy. Suppose take for example half mv square dividing by mm gets cancelled amma. V square by 2 is an again intensive property amma. So finally I want to conclude this one. What is property? Any observable characteristics of a system is known as property. Or properties are characteristics by which we can describe the physical condition of the system. We have two types of properties, intensive and extensive. Intensive means independent of mass or size of the system. Extensive means depends on mass or size of the system. Okay, we have seen just now pressure, temperature, density, specific properties. Okay, specific energies. Specific energies are intensive properties. Then volume, mass, okay, energies are extensive properties. Extensive properties. And we have seen the ratio of two extensive properties always intensive property, specific properties also intensive property, and specific energies also intensive property. Okay, with this I will stop at this point, but stay back. Okay, so are you following my class? If you are following, type in chat box, please. Okay, right. Okay, I will give my number, just to send a message hi to my number. I will give PDF notes for this class, just my number is 9010 552 Okay, this is my number. Yes. Okay, just to send hi to my number. Okay, I will give PDF. Okay, thank you. So do you have any doubts? If you have any doubts, I will clarify. Okay, are you following my class? Okay, right. Okay, what is total strength of the class,
No, sir. Only interested students are only joining, sir.
Okay, okay. Hardly 2 or 3 people. I can see here 3 people. Okay. At least inform your friends. They will join from next class onwards. Once they listen my class, they may get interest.
Okay, sir.
Right, Amma.
Thank you.
Thank you so much. See you in the next class.
Thank you, sir.
Thank you, Amma. Thank you so much. Madam?
Yes, sir.
Class అయిపోయింది మేడం.
Okay.
సో మళ్ళీ నెక్స్ట్ క్లాస్ ఎప్పుడు మేడం?
We can discuss in the mobile, sir. Please.
Okay. Thank you, madam. Thank you. I will call you, madam.